Let us begin by looking at the most common operating systems that we have. As you look at our page displayed on the screen, we have the different common operating systems that we have today. That is the Windows family operating system, the Unix family operating system, and then the Macintosh operating system. You will see that most of these operating systems are mainly defined by the company or the group of individuals that developed them. And we are seeing that today the most common operating system that is widely used today is the Windows family. Why is it widely used? It's because it is very easy to understand, easy to adopt to, and very easy to use. So at the end of the day, you're going to find that many people use Windows operating systems, but then there are other operating systems that you're looking at, like and then the Macintosh. My question can be, as we kick off today's lecture, which one is the latest operating system that you know under Windows? Which one is the latest version? Hello? Hello? Can somebody give us the latest version in operating systems, in Windows operating system? What are people using today? What is the latest version in operating systems when it comes to the Windows family? Which version is being used, or which one is the latest?
Windows 11.
Yes?
Windows 11.
Yes, we have Windows 11 as the latest version. And then the one below Windows 11 is? The version
Windows
below
10.
Windows 11 is what?
Windows 10.
Windows 10, that is correct. And then the version below that? What version is below that? Hello?
Windows 8.
Windows 8?
Yeah.
Okay. It is actually Windows 8.1 and then Windows 8. So let's first look at what we are calling the Windows family operating system. This is the kind of operating system that was developed by a company known as Microsoft. Like I told you that the different common operating systems are defined by the companies that decided to develop them. So the Windows operating system is or was developed by Microsoft, and since they started developing operating system, they began from Windows 1, and then they kept on upgrading. They kept on upgrading from Windows 1, and then they came up with Windows 2, and then they kept on upgrading to different versions of operating system until where we are today. So when you look at the latest version of Windows, that is Windows 11, there are features of artificial intelligence that have included in that particular version. So you find that people who are using Windows 11 right now are experiencing certain features that cater for artificial intelligence within the operating system. What we should understand that every version of the operating system had a different feature being integrated into that version. Every time they upgraded to a newer version, they added in features that could upgrade that particular version. For example, if you've been keen at the social media platforms or the different network communities that you guys are logged on to, yeah, every time they ask you to update a certain application or a certain software or a certain social media platform, sometimes every after an update, you're going to find that there are certain features that are added. You're going to look at your when you go to your features of emojis or anything, you're going to find that you'll find a newer emoji added onto your platform, one that wasn't there before. Yeah. When you keep on searching, you're going to find that there are newer features that have been incorporated in what you're already using. Now, this is what we are talking about, that as the different versions kept on being improved, they added in new features that could cater for people's needs or users' needs, end users' needs. You and me are end users. So at the end of the day, you find that this Windows family, they call it a family because it has so many. When we begin looking at or mentioning versions of Windows family, there are even more than 10. That is why I requested you to the latest, because we are interested in the latest ones that we are using right now. Yeah. So you find that the versions of Windows family are very many, more than 10. But each of the version came in with a newer feature, a newer component that would make our life easy. And now, like I told you, that in the latest one, that puts artificial intelligence features, meaning that making our work easy in order to use artificial version of the Windows family. So this is one of the type of the operating system that we want to look at. And we've mentioned the latest versions, and then the other versions, the way you're seeing them, they keep on going down until the first Windows, which is Windows 1 or the DOS, the disk operating system. So this is the Windows family, and that is all I can say about the Windows family. If we continue and look at what we are calling the Unity, this is another operating so used in Uganda. I don't know why we did not embrace this operating system, but when you do research about this operating system, most of the characteristics it has, Unix is very difficult to understand or to learn. Yeah. Why? It is mainly command prompt. I don't know whether you understand when I say command prompt. It is more of an operating system that uses commands. Yeah. For example, if you've ever been keen on your computer systems, the laptops, you click on the start button, and then you not the start button, you go to the search or taskbar, and then you enter a command known as a CMD, and then you press enter or you click on search. It's going to be for you a black screen, and then start working using commands. That is what like 4 collaborators who came together and developed this Unix operating system. It was a multitasking kind of system, and then it also helped in networking, making sure that there was a connection or sharing of information within different devices connected on a network. And then we are saying that this Unix operating system was very difficult to learn, but one thing that is highly recommended of this operating system is it is very secure. People who are using it love to use it because it is very secure. It can be used in their databases to secure confidential information that is very difficult to crack. So when these people realized that the Unix operating system was very difficult to learn, they devised a simpler version of Unix. And then they produced what we are calling the Linux operating system. I think that one you've come across it. So Linux came from Unix. Unix is command prompt, whereas Linux is the graphics version of Unix. When I talk about graphics version, is the Linux looks like the Windows operating system. The way we use Windows operating system, we open it up and then we click on start button and then we navigate the entire computer. That is a graphics design. But command prompt is always a black screen that looks like if you've ever witnessed somebody who is coding, that kind of screen they use for coding is also similar to command prompt. So we are saying that as these people realized that Unix was very difficult to learn, they decided to come up with a simpler version of their operating system, and then they gave rise to the Linux operating system. And we are saying that Linux is open source, meaning that it is free of charge. Most of the operating systems are sold. You only get it when you pay for it. But these people decided that their operating system was free of charge. It was open source. And anyone who uses it or who ends up using the Linux operating system is entitled to make modifications and changes in the operating system to suit whatever they want, meaning that their source codes are also very open to the public. You know, every time somebody designs an application, they make sure that they hide the source codes. You think about the people who have designed social media platforms, Somebody has designed Instagram, they have designed X, they have designed Facebook and all. They cannot share their source codes. They cannot share the way they design that particular application because they know once they share that, of course, they are going to get copycats and then somebody is going to produce the same thing as they did. So those are some of the it is some of the data that people really keep confidentially and do not share with the public. But when you see the Unix operating system or the Linux operating system, these ones, or the developers, decided that this was an open source operating system, meaning that the source codes were very okay to share with the public. So the people who are using Unix or Linux operating system do modify the source codes to suit the requirements of their particular company. So this is the Unix operating system that we are talking about. That one is also another type of operating system. And then lastly, we have the Macintosh by company. Like I told you that in order,
Excuse me,
yes,
I'm inquiring the Unix.
why is it that you're very low? Can you speak up?
Yeah, I was saying I'm inquiring about the Unix family. You said an example, or maybe click on the search bar and they type CMD, the black screen comes. So if that black screen comes, it means you're now using the Unix family as the type of operating system.
No. I said that the Unix operating system uses command prompt. And then I told you that when you click on the search button and then you type in the command CMD and click on enter or search, it's going to bring for you the black screen. That command prompt looks like what the Unix operating system looks like. Yeah, they look alike. Now that is a component that Windows operating system decided to design in their operating system as part of their operating system, but for people who want to use command prompt. I was bringing something that is relatable so that you can understand it, but I did not say that when you click on command prompt then that is Unix. No, I said that the command prompt, yeah, looks like, the design looks like the Unix operating system. And I said that the Unix operating system was very difficult to learn. Even you, when you open up that black screen and then somebody tells you that you start using it, for example, to type a document in MS Word, giving the commands and typing the document is going to be very hard for you compared to you opening up MS Word and then you begin typing from Microsoft Office. Are we together? Yeah? They look alike, but it is not that is Unix operating system. But Unix operating system just resembles the command prompt design. Are we clear?
Yes, madam. Thank you.
Okay. Any other question before I continue?
How can we, is it possible to access that operating system via online, that Unix family? Because you say that for them, they are free of charge. It's an open source and free of charge. You can easily access that operating system.
Yes, you can. You can get the Unix operating system. You can download from the internet.
Okay.
You can
Thank you,
download.
madam.
Yes, you can download from the internet, and then you will download the entire operating system, but they will also give you its source codes so that you modify according to your requirements. You know, every company has their own requirements and needs. So these people are open to their codings or to their codes so that you can change them to suit the requirements of your organization. For example, companies that are into transport and logistics. So when you want to modify a certain application to suit transport and logistics, then you are entitled to modify that particular application so that the requirements of transport and logistics can be incorporated into that application. This is what we are trying to talk about. So that is what we are calling the Unix operating system. And then when we go ahead, we look at the Macintosh operating system. And we are saying that this one was developed by Apple. Like I told you that these different operating systems are defined by the companies that developed them. The first one, Windows, is developed by Microsoft. Unix is developed by a group of people. They did not specify the name of their company, but it was like a group of friends who came together and developed Unix operating system. And then the Macintosh operating system was developed by a company known as Apple. And we are saying that Macintosh operating system was also designed based on the Unix version. Yeah. When you look at the Macintosh or the Mac OS, it has different features that were exported or were imported from the Unix operating system and incorporated into the Mac OS. Yeah. And then we are saying that this operating system was mainly designed for multitasking and also multimedia capabilities. What do they mean? That this operating system was able to have features like audio, like video, like images and movie making. Those multimedia capabilities were incorporated into this Mac operating system, and it was able, it helps the end users be able to exploit those capabilities in that particular operating system. But it had a problem that these operating systems were designed mainly for only devices that are designed by Apple. If you look at the different devices that you've come across, yeah, for example, hello, can you hear me?
Yes, madam.
Okay, I think I got an interruption from the network, but let me continue. As saying that the Macintosh operating system had a drawback or a problem, that these operating systems were mainly designed for only devices that are developed by that particular company. And I told you that I think we have witnessed this, that when you look at gadgets or devices from Apple, you're going to find that only operating systems or anything to do with the iPhones and iPads and everything is designed by Apple. There is no way you're going to get a version of Windows and then you put it on an iPad. No, it will not work. Yeah, you're not going to get a version of yes. Yes, I'm working on that as I talk. Yes, I can see that it's off. So I'm looking for those notes as I talk. I'm going to put it back. So I was saying that I think you've witnessed that all iPads, all iPhones, anything to do with the eye, everything comes from Apple. There is no way you're going to find a Mac, maybe a Mac device using something to do with Windows. No, for them, they decided that everything they design has to come from their company, from the operating system to the devices that they develop. So you're going to find that that is why in most cases, in countries like us here in Africa, we have not embraced we have not embraced iPhones to or anything to do with the Apple products to the maximum. Why? First of all, they are very expensive. Secondly, they have that problem. They do not cross to any gadget. But for you, when you go and buy a Samsung, you're going to find that it's going to be powered by Android. You go and buy another itel, you're going to find that it's going to be powered by Android. But have you ever found an iPhone powered by Android? And somebody testified to that you have an iPhone but is powered by Android. If I may ask you, what company developed Android? Yes, you should be knowing these things. Which company developed Android? What company developed Android? Dragon?
I think it was Android Inc.
Android Inc. is the company that developed Android?
Madam, is it Oracle?
Android Inc.
Yeah, it's Android Inc. Android Inc.
Android Inc. developed the Android OS that runs on mobile gadgets, you're sure?
Android Inc.
Firstly, it was Android Inc.
Founded.
And then Google took over.
For me, I think it is Google that developed Android. Google that developed Android, and then at the end of that day, Google went into an agreement with Samsung, and then they provide operating system for Samsung devices. Isn't it? Or I'm wrong? Okay, so we are saying that the Macintosh operating systems, they are developed by the Apple company, and they are mainly developed for Apple devices. So it's very difficult to find an Apple device that is using a different operating system running on their devices. For them, they decided that is what they are going to do. They are going to monopolize their own devices and create their own applications. And something funny, Apple is one of the richest companies in the world. You could say that, do you know what, since they decided to do something that is so specific, they are not rich. No, that is not the case. Even after being very specific, and they decide to only develop applications that run on only their devices, still they are one of the richest companies in the world. And we are saying that when you find these other devices that we are seeing around, when you look at the versions of computers, the different brands, you have Lenovo, you have HP, you have Samsung, you have all those different brands of laptops. You're going to find that all those different brands, you're going to install Windows operating system and it will run on those different devices. They don't even care what kind of company developed that particular device, they are going to run. But for the Macintosh and the Apple company only designs anything to do with their with their logo. Everything is developed from one company and it runs on their own devices. So that is the difference that you can say, or the feature you can tell from the rest of the operating systems that we have looked at. That is the Macintosh operating system. So when we continue, we look at what we are calling the system utilities or system program utilities. Somebody asked me about them earlier, and then I told them that we shall look at them. These utility programs come with the operating system, and we are saying that these are programs that are designed to analyze, to configure and to maintain a computer in simple terms. Or we can say that these are programs that provide a range of tools that support the operation and management of the computer system. Utility programs. Utility programs are referred to as the housekeeping programs. What do? They housekeep the computer system. How? These are the programs that scan for viruses. Utility programs or service programs. They are the ones that scan for viruses in our computer systems. They are the ones that are going to help you to compress a big file. You've come across big files, yeah? Sometimes when you cannot copy them to a certain device because it is too big. So what do? You compress it. These are the utility programs that help you do that. To compress a file, to clean up the disk. There are certain times when we clean up our disks, when we clean up our hard disks, yeah? Because sometimes they have a lot of unwanted files. Sometimes you want to get rid of certain files they've been on your laptop or your device for a very long time, and you want to do a disk cleanup. These are utility programs that are going to help you do that. So we call them housekeeping files or programs that help to maintain our computer system. And we are saying that examples, we can look at those that help in scanning antiviruses, the ones that help in compressing files, the ones that help in disk cleanups, and then the ones that help us in backups. Every time we want to back up our information on computer systems, then we use what we are calling utility programs. And then when we continue, utility programs, you can see examples. We have the text editors, the sort utilities, the file utilities, the tracing and debugging. When you look at debugging means identifying and removing errors. I think you've come across these utilities. When you decide to sort out a file, for example, you have a file that has names of students and they are not arranged in alphabetical order. Then you're going to sort them. Yeah, you're going to sort them so that we begin with students who are called Adong, Bima, Bong, whatever your names are that begin with A. So when we go and use the sort utility to sort names from A to Z, these are the kinds of programs that we use. They are called utility or service programs. And then to remember them properly, you can just remember that they are housekeeping programs. Are we there? As I go deeper, today I was insisting to have this lecture because I wanted us to follow on these slides. This particular lecture, as we go deeper, it is one of the most complex or difficult part of this course or this course unit or this topic. Yeah, so I wanted us to have this lecture so that we follow step by step on the screen, because in class we might don't even have a projector, so that you follow step by step, and then you can ask where you haven't understood. But please bear with me as I slowly for you to understand it. So those are utility programs. Remember, we are still looking at operating systems, and all these programs come with the operating system. When we continue, we are looking at what we are calling database management systems, and we begin by defining what a database is. And we are saying that a database is a well-managed and defined source of information. Well-managed and defined source of information. A database is that particular file or application in a system that helps you to manage and organize your information. For example, we can have class information about your students in this particular group, BCom, yeah? So we get a class list that mentions your name, your registration number, your student's number, then it mentions the program you're doing, then the campus you apply to. That organized information about you as a student is what we are calling a database. And then we are saying that database management systems are responsible for managing a database. The systems that are put in place in order to manage that kind of information so that it is well organized in a way that if they just want one particular person from a whole database of students, for example, you BCom students around 600 plus. But if I want to retrieve information of your course leader, then I'll ask your course leader to give me his details, his name, registration number and all. Then at the end of the day, I go into the BCom database and then retrieve only information for the course leader because that is what I'm looking for. So we are saying that database management systems are the ones that help to manage a database to enable users search and retrieve data needed to store, to update, and to manage. Hope we are together. That is what we are calling database management systems. Yes?
Excuse me, madam, I've not understood the difference between database and utilities because you talked about utilities helping you to, maybe you have names and then you're arranging them in order. How is it different from this database management system?
The utility program.
Yes.
Now, we said that utility programs are housekeeping, yeah? Housekeeping is, for example, I've given you an example that they scan for viruses. Housekeeping is maintaining the way the computer system is going to operate in a way that as it is operating, these service programs are going to make sure that no virus attack, yeah, they are always scanning the system to see that no virus has attacked that particular computer system. They look out, yeah, for any virus attacks. Then at the end of the day, you're going to find that when you want to clean up your computer system, your disk, like the hard disk, you know, we store so much information on the hard disk, and then it reaches a time when you want to clean it up, yeah, get rid of certain files and then bring in new ones. Those programs that are going to help you to clean up your disk so that you get rid of the unwanted files and remain with only the ones you want, those are service programs. But the database management systems help you to store information in an organized way. For them, their focus is about storage of information. And I've given you an example that when we want to create a database for BCom, yeah, we are going to get information about you students from your names, your programs, your students' numbers, your reg numbers, and anything to do with you students, like your date of birth. Yeah, and then we organize your information in a class database for BCom first year. Yeah, so when I want just information about one student from BCom first year, and I've given you an example, if I want information regarding the what? The course leader, yeah? When I go to that database of BCom first year, yeah, I would just click to, maybe I click on find, I don't know the name of your course leader, but I say find Mokasa Peter. in this database, you're over 600. But because it is a database management system, it will only look for that particular student, Mukasa Peter, retrieve him out and all his information, and then I'll be able to take it. Are you getting me? That is different from the other programs that are there to just see what is going to attack the system, make sure that there is a big file, they let us compress it so that it becomes small, then look for either organizing or sorting different names. That is very different from storage of information, organized storage of information. I don't know whether I'm clear with that explanation.
Yes, madam. Thank you.
Okay. So we are saying that we have what we are calling database management systems. And then when we continue, we are looking at what we are calling the network management systems. And we are saying that these are programs that help to diverse networks to communicate with each other. In every computer system, yeah, you're going to find that there is what we are calling a network interface card. Yeah, these cards or these particular devices help to connect to other devices so that they can communicate. That is the time you find that your laptop can be connected to your friend's laptop, and then the two of you can communicate through your laptops, through whatever network applications that you've connected to those two gadgets. So it is the network management systems that enable this communication or the network to take place. In other words, it helps network administrators to manage an independent component of a network inside a bigger network. The best example I can tell you that right now we are having an online lecture. I'm using a laptop to conduct this particular session. Some of you are using either laptops, some of you are using mobile phones. But it is the network management systems that are helping us to connect the different devices so that we can communicate. I'm communicating through a network and you guys are able to hear me. So that connection of different devices on a network, they are always managed by what we are calling network management systems. Are we together?
Yes, madam.
Okay. So when we continue. I think we go to you click on the start button and then you go to no, I think it is, I think we right click on the desktop and then we go to properties. I'm trying to do it here on my laptop to see where we can get the performance of a network. Either that or it is in control panel. I'm not so, I don't remember properly. But the monitor performance, it shows the performance of the entire computer system, whereby you can monitor everything that takes place or whatever you are doing. For example, if you open up MS Word or if you open up a browser like Chrome and then you work on it, at the end of the day, the performance monitors are going to show the activity you're doing at that particular time. They will show that this user has opened up a browser, and it is being used at this rate, and then they monitor the performance of your activity on the browser until you finish. I think in most cases, when you log off and then you go to an option known as End Task, I don't know whether you've come across that option. It is known as End Task. When you log off, log off your computer, then you go to End Task, and then when you click on End Task, it is going to take you to the performance monitors. You're going to see how your CPU is performing, all the programs that you are using on your computer system. The applications that you've opened, it's going to monitor the performance of that particular application. In case your computer hangs and at the end of the day you cannot close an application, for example, you cannot close MS Word, or you cannot close a browser, then you try to maybe before you think of restarting your computer, you can do what we are calling an end task. There are keys on the keyboard. I'll tell you about them. Then you end the task. When you go to that task bar, it is going to show you the performance of that particular application, and then you end it. When you end it, this way, your application is going to close. You're going to close it by force from the monitor performance or the end task page. These things are supposed to be very practical, but let me just walk you through. Those who have computers, maybe you remember and try it. But that is where we find the performance monitors. And then when we continue to the security monitors, those ones monitor the control access of your computer. These ones are in charge of the passwords. The way you create your password, the way you change your password, they monitor the security of your computer through the usage of passwords, the patterns, and all the codes you use on your computer system. These ones are the ones that are in charge, the security monitors. And then lastly, we have the computer application servers. These ones provide an interface between the operating system and the application. The ones that provide an interface between the operating system, Windows, and an application like Microsoft Word. The two have to connect together so that you can be able to, you should be able to use your computer system. So the interface between Windows operating system and Microsoft Word is what we are calling the application servers. Hope we are together. Like I told you that this one is going to be a little bit complex, but just listen in and then we continue. Then where you haven't understood, you ask. So those are what we are calling programs under the operating system. And then we move to system development programs. Remember, I told you that we have two categories of system of software. That is system software and application software. And then we divided system software into two categories. That is system development programs and system management programs. We've been looking at the system management programs, and now we are going to look at system development programs. We said system development programs are those programs in which applications are built. The ones that help you to develop applications is what we are calling system development programs. And we have examples of system development programs, that is programming languages and translators, programming editors and tools, and then the case, computer-aided software engineering packages. We continue and look at programming languages. We are defining then languages in which computer programs are written. Languages in which computer programs are written. When I asked you the other time when we were together, I asked you for examples of programming languages, and you gave me lots of examples. If we still remember, you told me we have Java, we have Oracle, we have Visual Basic, we have Python, we have C, C++. All these are programming languages, and they are the ones we are talking about right now. That they are those programs in which computer programs are written, where people known as programmers sit down and they begin coding in order to come up with an application. This is what we are calling programming languages. That these ones allow a programmer or end user to develop and set instructions that constitute a computer program. Today, you're going to find that today AI and all those newer versions in technology have made it very easy for people to adopt to programming. Nowadays, even an end user, even you can just wake up and then you begin coding because AI has made it easy. It's not like the other time that people have to go and study software engineering, they have to go and do computer science. No. Today, technology is becoming easier and everybody can code. So these are the kind of programming languages that we are looking at, and we are saying that programming languages are categorized into 5 categories. That is the machine languages, assembly languages, high-level languages, fourth generational languages, and then the object-oriented languages. When we continue, we begin with the machine languages. Machine languages and assembly languages, these are referred to as low-level languages. What do they mean by low-level languages? These are machine-friendly languages that are designed for.
Madam, your voice is low.
Okay. My voice is low. You cannot hear me? What about here? Am I loud enough?
Yes, now you're loud.
Yes, now you're.
Okay. So I'm saying that we are looking at programming languages. Yeah. These languages in which different programs are built or developed. And then I'm saying that we have categories of programming languages. 5 of them that we have just mentioned or looked at. That is the machine languages and assembly languages, high-level languages, fourth generation, and object-oriented. Now, this is what I want to explain to you so that you understand. We are not going to go into details because you're BCom students. We go into details for BBC students. But I'm just going to tell you what you need to understand about these languages. Low-level languages are the languages that were designed for the machine itself, for the computer hardware, that the computer understands only machine language. Yeah, it understands only the machine language. But at the end of the day, when these people developed the computer, they had to find a means by which a computer could communicate with the human being. Yeah. So the first languages that they developed were completely machine, whereby machines talk to each other and they understand each other using the machine language. And then those two, the first languages that we have, that is the machine and assembly languages. Those are low-level languages, meaning that they are the languages that are understood by the computer itself, or the computer hardware, or the computer architecture itself. And then with time, they had to develop languages that were human-like languages for us end users to understand and then convert so that the machine can understand and the two of us can communicate. So they came up with the high-level languages that were close to human language for us to understand and then convert it to the machine language so that the two of us can communicate. I don't know whether that makes sense to you, but let's continue. So when we are looking at programming languages, we look at the machine language and we are saying that machine languages, these are low-level languages directly understood and executed by the computer without translation. These ones consist of zeros and ones. Now the machine language constitutes of zeros and ones. That is the binary system, meaning that the computer system only understands zeros and ones. Now you and me as an end user, for us we come and look at the keyboard of our phones or a laptop, and then we start typing A, B, C, D, we type different letters. But what we don't understand that these letters are converted inside this machine, inside your phone. They are converted into binary system for the computer to understand and then send us back a feedback. But for us, just because we do not know the entire process that takes place in the machine, as we just type normally, but the people who program these machines that we are using, they made sure that whatever we type is converted into machine language and then converted back. There is a process of conversion and translation that takes place within the system, and this is what we are talking about. So we are saying that machine language was only understood and executed by the computer itself. That is in zeros and ones. And then when you look at the next programming language, which is the assembly language, they wanted to make a better version of the machine language. And so they came up with assembly language that uses mnemonic codes. What are mnemonic codes? These are codes that appear in word-like words that are related to our language or to something that humans understand. For example, in assembly language, when you want to add, you say add as a command, that add, add. And you want to subtract, you use sub, sub, to subtract. But at the end of the day, as we are seeing them as short forms of words that we already using. But during that time, as they kept on developing this, they came up with the assembly language where those words came from. Add to mean addition, add was a mnemonic, and then sub for subtraction as sub. Are we together until that part, or I'm speaking French?
French,
It's okay.
madam.
It is okay. Yeah,
Swahili.
it is okay,
Please,
madam.
please, whether I'm speaking French or English, I do not have a simpler version for this particular part of the course. Yeah? Software, we do not have any simpler version for what? System development. Programming languages, we do not have any simpler version. It is what it is. So please, let's just try to understand the simple bit that I'm trying to explain. Then the others those are for BBC students. They decided to go in that course because they wanted, I think, to learn more about computers. But
Madam.
that is it. Yes.
Please pardon on the explanation of assembly language.
I said assembly language. Assembly language, we are saying that these are low-level languages in mnemonic codes. Yeah, mnemonic codes similar to the machine codes. And we are saying that these ones, they place short codes in a place of numbers. Now, instead of, I told you that this was an upgrade. Instead of zeros and ones, yeah, instead of zeros and ones, because the first language we are talking about is the machine language. And I'm saying that the machine language is zeros and one binary system. If you remember binary system, it is just zeros and ones. And you and me understand when we type letter A, alphabetical letter A. But alphabetical letter A has a different version in binary system. You're going to find that letter A is 010101 in binary code. Yeah. So we are saying that at first when they developed these machines, yeah, of course they had to make a machine understand what a human being is going to tell it to do, to program it. So they stay making a machine understand using the binary system. Those developers, whoever were the first to develop computers, they started making these machines understand using the binary system. But then they realized that, you know what, the binary codes were difficult. They needed to make it a little bit simpler. So they introduced assembly language to be a better version of the machine language. And then this one, the assembly language, we are saying that they are languages in mnemonic codes. The mnemonics are the ones I'm talking about. I don't know another name for mnemonics, or you can just say the short forms of words like addition. Yeah, that was the version they came up with. That instead of using zeros and ones to mean add this number, add 1 and 2, they decided to come up with a mnemonic or with a code known as ADD to mean addition. If you want to subtract, they came up with a mnemonic known as SUB, S-U-B, for you to understand they want to subtract two numbers. But this was a better version of the 0101. Imagine you want to add 1 plus 1, and then you have to say 010101, then 0101 plus 0101. It wasn't making sense. For us now, we see that it wasn't making sense, but that was what was there before. So we are saying that assembly languages are those languages that are used in mnemonic codes. Are we together?
Yes, madam. Thank you.
Mnemonic codes. See the word on the screen, mnemonic? Yeah,
Yes.
I do not have easier name to call it because it is what it is. And then when we continue, we are saying that the languages were divided into two. That is the low-level languages and the high-level languages. These two were the two low-level languages that were first developed, and we are saying that these ones were developed for the machines themselves, for the architecture or the hardware of the computer system. And then as these programmers kept on developing, they came up with high-level languages. These ones were close to the human language, a language that we understood as human beings and we are able to communicate with the computer systems. So in high-level languages, we are saying that these are programming languages that are used to develop programs closer to the human language. And then we are saying that examples of high-level languages are the ones that we are familiar with, like C, C++, we have C#, we have Python. All those are started coming in as high-level languages, languages that were close to human language that we could understand and then translate for the computer so that the two of us can interact and understand each other. Those are high-level languages. And then as technology kept on changing, they say upgrading. You know, with technology, we keep on upgrading from a lower version, we keep on upgrading to a better version. So as technology kept on upgrading, they kept on upgrading in programming languages. And then they came up with fourth generation languages. And then we are saying, as they kept on bringing new languages, these languages were closer to English or to human being language, or languages we understand. If some of you have come across softwares like SQL, yeah, SPSS, these are softwares that help us to analyze data, to handle databases. When you look at those applications, all those softwares, the way they were designed, you will understand the kind of programming language that we are talking about. Right now, I cannot really explain it in theory for you to understand. It needs a practical bit of it, but the practical bit of it is not meant for BCom students. Let's just understand what they are, and then we just continue with that. So we are saying that we have fourth generational languages that kept on being upgraded in programming languages to get closer to what human beings understand, and then so that they can interact with the machine. And then when you continue, you find what we are calling the object-oriented languages, which ones we are defining as languages that enable programmers to define data types, structures, and operations that can be performed on objects. Now, the best example I can give you about an object-oriented language is the version of, I think you've heard about self-driving cars. Yeah? I assume that we have all heard about the self-driving cars. These object-oriented languages were developed so that they can be performed on objects. For example, the self-driving car, whereby you program a car to drive itself minus a human being. Yeah, this is what we are calling object-oriented. That a car was programmed from scratch to be driven by itself and not a human being, meaning that they got an object, which is the car, as the object, and then they put in a version, a computerized version of a programming language that enabled it to be able to drive itself minus a human being. Am I still speaking English?
Yes, madam.
Yes.
Somehow.
Yes, I know this topic, yeah, but it is what it is. But very interesting though. I don't know whether me, the person teaching it, I find it interesting, but I feel it is very interesting. So that is what we are calling object-oriented languages. So you're going to find that we have so many examples of object-oriented languages where they've been integrated. Self-driving cars, we have different appliances, yeah? Look at all the smart appliances that you have in your homes, from your coffee makers to your microwaves, all those smart objects that you have, they have been programmed by object-oriented languages. For example, the Visual Basic, the Ruby, the Python, the C++, these languages have been programmed, yeah? They have programmed different objects that at the end of the day, you go and command an appliance, or you put in a command in an appliance, and then you leave it to do the rest. Yeah, the smart homes. Yeah, all those are object oriented. At the end of the day, you reach your home, and then you're welcomed by an AI, then your lights just switch on themselves by a command or something. All this is because of the object-oriented languages. But remember that when computers were first developed, they first started with the machine language. The people who are developing those computers first devised a means of making a computer understand its components, yeah, its component, its architecture before we human beings say understanding it. And then these guys, I think they were geniuses, because at the end of that day, they knew that they cannot leave this knowledge or to stay with this knowledge, but they had to make sure that they make it simpler so that at the end of that day, everybody understands the computer. Today, we have people who do not even want to try. You tell them, you know what, let's learn something in IT. They're like, you know what, I hate those machines. But they love using the phone. Some people don't even know that mobile phones are computers. Yeah. They will tell you, you know what, I can't do without my mobile phone, but I can do without a laptop. I don't even want to use it. Yeah. But they are all computers. Even your mobile phone is a computer. Even your digital watch is a computer. So you're going to find that there are people who want to remain traditional. They do not want to embrace technology. They do not want to know about these things. They want to remain in their traditional world. But guess what? We are moving into a transformed digital world. We are not going back to traditional ways. We are not going back. So like I told you earlier, please get a digital skill. Get a digital skill, add it to your BCom, and then you're going to enjoy life, or you're going to move smoothly. But if you're going to do this particular course minus anything in technology, then you guys, I believe getting jobs out there might be a little bit harder minus a skill in technology. Please take this seriously. Take it seriously. Get a digital skill. Get a digital skill. You should know how to use computers one or the other. Get a digital skill. It is going to help you a lot as you navigate in this world. Okay. Then when we continue, we have what we are calling language translator programs. And we are saying that, yes?
Madam, I have a question. About machine language. You said this one like was enabling like computer hardwares to communicate. So like in layman's language, is it like maybe how you get maybe a desktop, then you connect a keyboard to it, and what you're typing on the keyboard is able to be displayed on the desktop? Is it more of that?
When I talk about the architecture of a computer, I'm mainly talking about what makes up the computer inside. Yeah. Like when you look at components like the motherboard. I don't know whether you guys have seen what a motherboard is. And then you look at the architecture of the motherboard, that it has slots, it has different components on that board. Yeah, its architecture on that board. The way those components on a motherboard connect to one another and be able to know what each component is supposed to do in that computer system is what I'm mainly talking about. Before we even come to the keyboard or what we are seeing outside, I'm talking about what is happening inside, yeah, whereby the CPU is communicating or is connected on the power supply, and then there is a battery, and then there are slots, and then they are connected to the hard disk. Whatever is happening inside the CPU is what is mainly we are talking about as the architecture of a computer system. And the machine language is dealing with the connection of those different components so that they understand each other and be able to produce what we want. Because at the end of the day, every time you open up your mobile phone, yeah, you open up the back of your mobile phone and then you just look at the architectural design of everything that is there, yeah. You know, us, we don't mind because we are end users. But have you ever opened that phone and you see how they design those small components that are next to each other? The different small wires, the different how they are all connected to make this piece of hardware. And at the end of the day, we can talk through it and then the other person receives. Yeah, that is the architecture we are talking about. How those different components were connected together so that at the end of the day, when we speak, I speak from Uganda and then somebody in the US can hear me. This is the architecture we are talking about. Whatever is happening inside there. So it is the machine language that was first introduced to make sure that those different components we are talking about inside that machine can connect to one another and understand that, you know what, when I need to be switched on, it is the power supply or the battery is the one that is going to be working. It is the one that is supposed to give me power. Then at the end of the day, I'll be able to be switched on, and then this and this and this, the whole play of a computer system. Are we together?
Yes, madam.
Okay. So when we continue, we are still looking at programming languages, and then we are looking at what we are calling language translators, translator programs. And we are saying that the programming language translators are programs that translate other programs into machine language. They translate other programs into machine language. You know what that means? It means that, like I told you, that the machine language is only understood by the computer. Then there are translator programs that help to translate machine language into what we understand. So the language translators, we have 3 programs, that is assemblers, compilers, and what we are calling interpreters. Yeah. And we are saying that these ones are the ones that help us to translate whatever language we want into machine language so that the computer can understand, and vice versa. So when we look at compilers, these ones are going to translate the entire code. Yeah. The entire code, that whatever code that you have written in the different languages, it translates the entire code back to machine language. You know, this entire computer system is all about what end users ask the computer to do, and then the computer is going to send back. Yeah, that is why we tell you that garbage in a computer, you're going to get garbage out. When you give it a command, this one is a computer that is programmed. When you enter garbage into a computer, it is going to give you garbage out. So at the end of the day, we are saying that these translators are going to translate the entire codes of a given programming language. They translate the entire code and then they translate it into machine language. Then after it is translated into the machine language. The computer will interpret it, know what you want, you're commanding it to do, and then after it is going to translate back into what you understand, into English, and then send it back to your screen. The compilers are helping you to do that. Are we together?
Yes,
Yes.
madam.
And then we are saying that when you look at interpreters, interpreters are going to translate and execute codes line by line. Yeah? You're going to find that there are certain programming languages. The first one is translating the entire code. That when you write an entire code like a full page, for it, it's going to, as a compiler, it is going to translate the entire page and send it to the computer in machine language. Yeah. But this interpreter, for it, it's going to translate line by line. It's not going to get the entire page to be translated. It's going to go line by line of your programming language and then send it to the computer. And then the computer will get it, understand it, get whatever you're commanding it to do, and then send back. Yes. So that is what we are calling the work of this particular interpreters. They translate and execute line codes all line by line. And then lastly, we are saying that the assemblers convert assembly language into machine code. Assembler is another language translator that converts the machine language into machine code. For it, it's going to get the machine, it's going to translate assembly language into machine code. Translating the other mnemonics I told you, the add to machine language or machine code, to zeros and ones. Somebody has sent a message that Madam send slides. You think this information is in detail? The slides are these ones I'm talking about. But the detailed information I'm giving you is not in the slides. It's not anywhere in the notes. I give it to you to understand it when I'm teaching, and for you not to forget, but it's not anywhere in the slides. Even if I send you the slides, you're not going to find this information anywhere in detail. Yeah? That is why I told you that please always attend classes. Why? When we are teaching, we give more information than what is in the notes. We give detailed information in class when we are teaching. So sometimes you're going to miss class and then you think that, you know what, I'm going to get the notes and then I cram. Then you're going to look for this information, compilers, interpreters, assemblers. They are there as examples. You're not going to find anything in detail. Okay, so we have what we are calling the case tools. The case is the computer-aided software engineering tools. And we are saying that these tools combine into a single application with a common interface to be used at the different stages of development. When let me just give you an example. When we are developing an application, it has what we are calling different stages. It undergoes to develop an application. When I talk about an application, think of applications that you're using. For example, you guys are fond of you love movies. Think of an application like MovieBox. Now, this particular topic, we are looking at how MovieBox was developed. We are looking at the back end of MovieBox. This is what this topic is about. So, these case tools, they combine the tools into a single application with a common interface that is used at the different stages of system development. What stages am I talking about? When they are developing an application like MovieBox, there are certain stages they follow. For example, it begins at the planning stage. Yeah. You begin by planning an application, and then you design you go on from the first stage is planning, and then the second stage is designing. Yeah, or it is putting requirements together and all, and then the third stage is designing, and then the next stage is testing. You test that application before you give it to us to use. One thing you should understand, that all these applications we are using, from Facebook, WhatsApp, they all underwent these stages. They planned them, then they put all the resources and requirements together, and then they started designing. Designing is coding. They started coding this application. After they coded, and then they came up with a product, they took it for testing. Actually, when you look at those applications like WhatsApp, like Facebook, they are not even tested in countries where they are developed from. No. If an application like WhatsApp was developed in USA, they are going to send it to China for testing. China, India, Japan, they are going to send those applications there for testing. Why are they testing? To see whether there are errors within that application, identify different errors or anything that has gone wrong, and then remove all errors before they can send it to us, the end users. That is what they do, people who develop applications. So we are saying that under CASE, these are tools that help to combine into a single application that helps a programmer to undergo those stages of development. I've told you that the stages begin from planning, then putting requirements together, then you design the application, then you test the application, then you deploy to ask the end users to use it, and then after you've deployed, you begin maintaining. That is why at the end of the day, you always receive a message that your application needs to be updated. They send you messages on WhatsApp. We need to update. And what do you click? Never. You click never. They ask you, we want to update every after 2 weeks or a month or 4 months. Or then they put the option never, because you guys don't want to be disturbed and you forget that that application is not yours. So every time that message pops up, what do? You click never, never, never. And then what happens? You just wake up one day and you're off WhatsApp. And then you start calling your friends. You know what? I don't understand. I'm off, yet I have data bundles, yet this and that. You refuse to update. That is the reason. And when you keep on clicking, you're going to find that you're going to find yourself in the App Store to update that particular application, so that after updating, you come back online. I think we have all experienced that. And this is what I'm telling you, that the work of these CASE tools is to make sure that they follow up on all the stages of development. And I've just walked you through the stages of development for WhatsApp. That at the end of the day, they woke up and they planned for it. They put all the requirements for that particular application, WhatsApp, and then they began designing the application. And then after designing, they sent it to different countries for testing. That is China, India, and all those countries that are good in technology. After being tested, it was sent back to the US, and then the owners, Mark Zuckerberg and his friends, deployed it into the world. Me and you, we logged on to these platforms. And then the last stage of development is the maintenance. They are always maintaining. They send us messages when they want to update. update, upgrade. And then at the end of the day, you're going to find that every time they make those updates or upgrades, you're going to find that you find a new feature in your application. That is when you find a new emoji that wasn't there before. After updating, you're going to find that you're going to find a new emoji and you're like, but I didn't see this one before. Yes, this is what they do and this is the work of these tools. Are we there?
Yes, madam.
Okay. And then when we continue, remember that we are still looking at system development programs, and then we are looking at what we are calling multi-programming and multitasking. Still somebody talked and asked me about that earlier, and then I told you that we are going to talk about it. Multi-programming is the ability to execute multi-user programs concurrently through sharing of computer resources. What do they mean? This means that computer programs are stored in the primary memory. Primary memory is the RAM and ROM. I think they told you about that. Somebody is asking me what is SDLC. By the time you ask me that thing, you know what it means. System Development Life Cycle. Haven't you come across that? System development life cycle those are the different stages of development any application or software undergoes before it is given to the end users to use. Yeah. So that is how they abbreviate it, SDLC. So we are talking about multi-programming, and we are saying that multi-programming is the ability for multi-user programs to concurrently through sharing of computer, the ability to execute multi-user programs. What do they mean? That there are a number of programs that are stored within the computer's main memory. Main memory in the CPU is the RAM and ROM. So there are certain programs that are stored in the main memory that always wait for execution by the CPU. And it is in the design of a computer system that the CPU is supposed to have idle time, that it processes and then it has to reach a time when it has to rest. It is called idle time. But during that idle time when it is supposed to rest, because there are certain programs that are stored in the main memory, they don't allow the CPU to rest during idle time. It keeps on executing different programs one after the other. Why? These programs are mainly stored in the main memory, in the primary memory, temporarily. So they keep on coming up to be executed. And during that time when these programs are being executed, taking up the computer's idle time is what we are calling multi-programming. And then when it comes to multitasking is about carrying out different tasks at the same time on a computer system. You as a user carrying out multiple tasks. For example, right now you're listening to me or you're having a lecture right now on your mobile phone. But as you're listening to me, you decide to minimize the Zoom and then you start sending messages to your friend, or you open up in a platform and then you start chatting. At the end of the day, you're multitasking. You're listening to me on Zoom. At the same time, you can open up Facebook and then you chat. At the same time, you can decide to do something else, or you send you send a report or a file from your computer, from your mobile phone, and send it to somebody else, and then do anything else. But at the same time, you're listening to me as I'm lecturing. That is multitasking. Where is the difference? The difference is you and me, we are the ones multitasking. Yeah, we are the ones multitasking on our computer, but multi-programming is happening inside the CPU. We cannot even see it. Yeah, it is happening in the CPU, that there are certain programs that are saved in the memory, and they are utilizing the CPU's idle time to be to execute, to be executed, or to carry out activities. But multitasking, me and you as the end users, we are carrying out different tasks at the same time. Yeah, like having a lecture right now, and then you decide to open up a social media platform, and then you start chatting with somebody else while you're listening to me. That means that you're multitasking. Have we understood?
Yes, madam.
Even saliva is out of my mouth. I've run out of it. Any questions till that part?
Madam, you said that the CPU temporarily deals with these certain programs while the RAM and ROM are resting, right?
While the RAM and ROM are resting, no. I said
The idle time,
CPU,
yes. The CPU,
the
yes.
idle time, the CPU is the one supposed to rest, not the RAM and ROM. The RAM is the one that holds the programs that continue executing during idle time of the CPU.
Oh.
Yeah.
Okay. Thank you, madam.
So, do we have any questions before I leave you to go and enjoy Easter? The way you didn't want me to teach, I wanted to teach you because I wanted to get over with this topic, that complex one. Then the others are going to be very easy, but at least I know that one is out of the way. Do we
Madam,
have any questions?
yes.
Mm.
So these ones that we have been looking at, the programming languages, the translators, then the multitasking and multi-programming. The case tools, are they just examples of the system development programs?
Yes.
Okay.
They come under system development programs. Okay.
Yes, my question, please. Excuse me. Good afternoon, madam.
Good afternoon.
I am requesting if you can dissect more on what you mean by idle time. Thank you.
Idle time. No, now idle time means computer systems were designed in a way, you know, that it is the work of the CPU to process data. If you understood the topic of hardware components, I think they taught you hardware components, and then they taught you the CPU. At least, am I clear that you guys were taught hardware components?
Yes.
Okay. So when you came to that part of the CPU, yeah, they told you about the parts of the CPU, and then they taught about the RAM and ROM. They taught about the main memory, yeah, the main memory, the primary memory, and then the secondary memory. But then they talked about the CPU as one that really processes data, yeah, into information. We all know that data begins from the input, then to the process, that is the CPU, and then it goes to storage, and then output and everything. But during that time when data is being processed, yeah, we are saying that it was designed, these computers were designed in a way that the CPU has to have resting time, which they call idle time. Yeah. Of course, you know, sometimes when your computer overworks, yeah, especially most of you who have gadgets from China, when you overwork them, especially those ones that are not original, when you overwork them, it hits up like it's a time bomb, like it's going to explode. Yeah. So what am I saying? That there are certain, it was designed for these gadgets to have idle time. You have to let it rest after overworking it. Otherwise, if your computer is not original, or if your gadget is not original, if you overwork it, it's going to break down. You just wake up one day and then your phone just stops working. It just blacks out. It has had enough. Meaning that even the time when it is supposed to be idle, when it is not processing anything, because you keep on using it, it's not going to have any idle time. It's not going to rest. It's going to keep on working until it crashes down. So computer idle time is that time when the CPU is not supposed to be in motion. It's not supposed to be doing anything. It just has to be idle. It has to rest from processing or anything. It just has to be idle. But we are saying that multi-programming means that programs continue to execute during idle time. The time when the CPU is supposed to rest, these programs do not allow it to rest. They keep on executing during idle time. That is what we are calling multi-programming. And then different programs that are stored in the computer memory or primary memory are the ones that keep on coming for execution. Yeah, because they are the first to be executed by the CPU. So they keep on coming in, even during the idle time for them, because they are stored in the primary memory, they just keep on coming in during idle time. It is what we are calling multi-programming. Have we understood?
So,
Yes,
madam,
yes.
now, madam, me what I want to ask, when those programs are being executed, it's the RAM that is working with those programs, or they're just working like
Remember the RAM is a temporary storage.
memory? Yes.
For it to work is to make sure that it's holding those programs until they are executed. It's just a temporary storage. It is like keeping the programs in line as the CPU is working. Yeah, that when one program is done, the RAM sends another one. Its work is to send those programs lining up in the RAM to be executed.
Okay. Okay. I've
Yeah.
got it, madam. Thank you.
Okay. You're welcome.
Madam, I have a question.
Yeah.
Like when you were talking about the types of operating system, you said we majorly have the three, the Windows, Unix, and others. Then later we started talking about the utilities, database, network, then performance monitors, and all those. Are they also?
They come with the operating system. Those other programs come within the operating system. That when you install the operating system onto your computer, and then at the end of the day, you click on the start button, and then you see that Windows has been installed. Yeah. Those other programs come within the operating system. They come inside the operating system. That once you install, you've installed everything, but they come with the operating system.
Including Macintosh?
No, Macintosh is another operating system. I said there are three. There are three types. There are three families.
Yes,
the
madam.
Windows operating system, the Unix operating system, and then the Macintosh operating system. And I told you they are defined by the different companies that develop them. But then these programs, the service programs and all we talked about, they come with the operating system.
Yes, madam. Now my question was, because we said for Macintosh, for it is designed uniquely in that it is on it only operates on like only
On device.
devices that have something like that. So these other programs are also included in the Macintosh, or they are only to the Windows and the Unix.
Now you're going to find that when you look at the Macintosh operating system, you might find that those programs are there, but they are not called what? Utilities. For them, they are going to have a different name. Now these are names that were developed by this particular company, Microsoft, for Windows. Yeah. So you're going to find that in Macintosh operating system, maybe Apple calls them something utilities, or for them they have a different name. It is according to the company and what it wants to call those particular programs.
Okay.
Yeah. So you can go and search on Google and you ask it that if Microsoft calls these utility programs, what does Macintosh call these other programs in its own operating system? What are they called? I'm sure it will give you the answers to that.
Okay. Thank you so much, madam.
You're welcome. Okay, if we don't have any other question, I wish you a happy Easter. Enjoy. I told you system development life cycle, SDLC, system development life cycle. That is SDLC in full, system development life cycle. Okay, happy Easter. God bless you all.
Likewise.
I'll share the notes. As soon as I finish with this topic, I'll share the notes. Don't worry about it.